Yuri, look at that window. It looks kind of like a sunny day, doesn't it? Look at that sunshine, that insulation. Oh, Yuri, you made me like a whole book here, huh? Look at how fancy Yuri is, the little fancy edges and everything. Nice artwork there, pal. So we've got a bunch of these things. Let's go through them one at a time. We're going to kind of touch on some different topics. Sunlight for this video and the next couple of videos is really the focus. Okay, so for this first one, greenhouse effect. Short in, long out. That's what terrestrial radiation's all about. Here, you got some good rhymes. All right, so you see the greenhouse, that kind of is the analogy for what the Earth's atmosphere does. So you get these short waves that come in. Those were mostly visible light and some UV light, okay? And they're shorter, not because of the length of the whole thing, but from peak to peak to peak, or trough to trough to trough, okay? Crest and trough. Wavelength is how many little wobbles there are in the wave. So those are shorter. The shorter the wave, the easier it can go through things. That's why things like UV light can damage your skin and can cause cancer, because the UV light is short enough where it gets through, it penetrates your skin a little bit. Okay, so the short waves go through the greenhouse or through our atmosphere. They hit the greenhouse or they hit the surface of the Earth in real life, and then they lose some energy. And when that longer wave tries to get out, it can't get through the gas. Or on Earth, it can't get through the gas. Did I say gas or glass? I can't keep track of what I'm saying. In the greenhouse, it can't get through the glass. On Earth, it can't get through back some of these gases. These gases help to trap that longer radiation. So those are super important to know. You got to memorize them. We'll put the full words over here. CO2 is carbon dioxide, most well-known one. H2O, water vapor, is a good trapper of gas, greenhouse gas. I'm just misspeaking all over the place. It's a gas heat trapper. It's a good trapper of heat. CH4 is methane. That traps the long radiation. And CFCs, that shows up a little less often, but chlorofluorocarbons, those are four gases. They're like blankets for the Earth. So the sunlight comes in, and then it tries to re-radiate. That's called terrestrial radiation. And the radiation coming off the Earth, if we have blankets, like those four gases, it traps some of that radiation and it regulates our temperature. So greenhouse effect is super important. It's why the Earth is the livable temperature that it is. The moon gets the same sunlight that the Earth gets, but the moon's temperature changes drastically because it doesn't have those gases. So at nighttime, or the moon's nighttime, the sunlight, the moon radiation just cools off the moon super fast. So we have those gases that help regulate our temperature, keep us warmer. Okay, so you got to memorize those four gases for sure. Short in, long out. That's the greenhouse effect, and it's a really good thing. Okay, now when we're talking about that insolation coming in, there's different factors that affect it. So insolation stands for incoming solar radiation. Repeat that one more time. Insolation is incoming solar radiation. They put those words together. And there's two different ways that they'll describe that. There's the intensity or the duration of insolation. So intensity is strength, duration is length. You're a good rhymer, Yuri. So intensity, that's the angle of insolation. The steeper the angle, like this one here, it's going to strike at a more direct strike, and it's going to heat up that ground faster. The more of an angle, the more that you're going to get some reflection coming off of there and not as much absorption, and it's not going to heat up as fast here. Okay, and then duration, how long is that sunlight out for? So New York State, our summers, we have about 15.5 to 16 hours depending on where you are in the state. The further north you go, it gets closer to 16 hours of daylight. The opposite in the wintertime. So our duration changes throughout the year. The longer the sun's out, the more heat we can absorb. And then one other thing, I didn't make a whole, or Yuri didn't make a whole card for it. Different colors. We pretty much are, that's a review from middle school, but darker colors will absorb more and rough texture things will absorb the most. So light colors reflect, shiny things reflect. So like the pavement, it's rough and it's dark, it's going to absorb the most sunlight. All right, now relationships. That's the format that you should always try to write a relationship in. That's what we've used this year. It helps you think through describing a relationship. So you always could put direct, indirect, but it's better to think through it like this to make sure you're describing the relationship right. So as the first thing goes up, the second thing, and you usually have to pick, goes up or goes down, could stay the same. Okay, so we're going to describe some different relationships with insulation that you have to, know. So the first one, as latitude goes up, intensity is going to go down. So what that means, higher latitudes, the North Pole or the South Pole, those are the highest latitudes. So when you get closer to the North Pole or the South Pole, the intensity, how strong is that sunlight? It's going to decrease. Okay? And then this one's a little trickier. I'm going to cover this one up here. As latitude goes up, what happens to the duration? That depends on, I need to be a little bit more specific. If I'm talking about in June, that's going to be one answer. In January, that's going to be a different answer. But if I'm looking at the whole year long, it's actually going to be the same. Everywhere on Earth gets the exact same amount of sunlight if you take the whole year into account. If you're talking June for New York State, well, for the whole northern hemisphere, as latitude goes up in June, duration would go up. The closer you get to the North Pole, the longer the sun's out. As latitude goes up in January, it'd be the reverse. The duration would go down. We have shorter days in January, but over the whole course of the year, the exact same. And then another one, as far as temperature and throughout the year, we are going to do a whole separate video on, me and Yuri, are going to do a whole separate video on the seasons and the diagrams that go with the seasons and describing that. But this one fits in a little bit with what we're doing now. As far as relationships, proximity to water and temperature variation. So as you get closer to water, the temperature variation is going to go down. What does that mean? When I look at a graph like this, I took two places that are pretty much the same latitude. So they get the exact same amount of sun, the exact same strength or intensity of insolation. Phoenix and Myrtle Beach. They're both like 33, 34 degrees latitude. Phoenix is the desert. There's no water in the desert. Water helps to trap heat, energy. So if you're not near water, your temperature is going to fluctuate quite a bit. If you are near water, your temperature is going to even out quite a bit. This could be throughout the year, this could be throughout the day. But Myrtle Beach, temperature is going to go up slower and decrease slower on average, and Phoenix is going to have a much bigger temperature variation. Even if this is one day, that's why I put time down here, Phoenix will get super hot, but the desert gets really cold at night. And throughout the year, the same thing will happen too. Water moderates temperature change throughout the year. So even if the two places get the exact same duration and intensity, you still can have temperature variations based off of other conditions. So I think those are all four of the things. We'll do some review questions, and then you'll see me back here when I, come back through something that I forgot, like I usually do. Good job with the high five. Ask some questions too. If something doesn't make sense, I haven't remembered to say this on any of the videos, ask questions in those comments. I look at them, I'll try to answer them, explain if something doesn't make sense, and Yuri will chime in too. He'll give out free high fives if you ask a good question. All right, let's go over some of these different questions. There was a bunch of different topics, so we're kind of bouncing around a little bit here. And I combined some questions, not that they really go together, just because it's easier for me. So equal areas of which surface absorb the most. So that's the opposite of reflect. What's going to absorb the most? You got dark objects and rough objects. So the black top absorbs the most. If the question was reflects the most, a white sand beach would reflect quite a bit. A lake surface, partially melted snowfield would probably be the best reflector, but they wouldn't ask with these four options for that question because it'd be difficult. Which factor has the greatest influence on the number of daylight hours that a particular Earth's surface location receives? Number of daylight hours is my key there. So, duration of insolation. What's going to affect duration? How long is the sun out for? Latitude. So, North Pole gets 24 hours in the summer, 0 hours in the winter. What graph best represents the relationship between latitude and average temperature? So I gave you a way to describe relationships with words. The way that I also like to work through these things is I'll draw a little graph myself, and I've mentioned this before. Okay, those are great lines. So latitude, if the latitude is low, what's going to happen to the average surface temperature? So 0 latitude, that's like the equator. Oh, the equator's hot, so I'm going to put a dot, big dot, right up there. And then the North Pole would be 90. So the North Pole, what average temperature is going to be lower at the North Pole. So if I make my 2 dots, then I connect the dots. That helps me to pick which graph goes when I'm describing a relationship as far as graphs are. I like to make dots. New York State, summer's warmer than winter because summer New York State has. So 2 separate things. Always makes a question a little more difficult. So let's think about it and cross off options. Hours of daylight in the summer than winter. They like to do this back and forth thing, which I've brought up before. Make sure that you're thinking in summer. So it's a summertime question. Okay? They throw in the word winter once or twice. Make sure you're answering based off of the proper conditions. So summertime, we have a lot of hours of sunlight, so we have more. So it's one of these 2. It's not those 2. Low angle or high angle. Versus the winter, we're going to have higher angle. It's going to come in steeper. Average temperature at Earth's equator is higher than the temperature at the South Pole because this is the same thing. They really ask questions. I call it like a head fake. They talk about the equator, they talk about the South Pole. Make sure that you're answering based off of the South Pole here, not the equator. So try to pick your answer there. What does the South Pole have versus the equator? The South Pole has less intense insolation. Nice diagram here showing different angles. Greatest intensity, you just pick the biggest number. Biggest number, it's the most intense sunlight. This is a confusing bar chart. They like to throw graphs and see if the student can interpret the graphs. Make sure that you're looking at the whole thing. You read up here, there's 4 different latitudes, there's different dates, there's a lot going on. Total numbers of daylight hours during an entire year. You can use the graph and you can add up each of these, add up all 4 and get a number, but you should know that it doesn't matter. Duration of insolation over a whole year is going to be the same no matter what. But if you needed to, you could use the graph, add up each of the 4 seasons, and get a number. Land surface produces the greatest absorption. So absorption is the opposite of reflection. What's going to absorb the most? Dark colors, cross those out. Rough absorbs more. Not crazy about this diagram. It's just usually they would draw a diagram and you're zoomed right in on one surface of the Earth, but they like to mix it up, so I picked this one because it was probably the most difficult. Short in, long out, that's what terrestrial radiation's all about. So short in is going to either be A or D. Long out. You might be asking, why doesn't D work? It doesn't show anything about going out. So the short goes in all the way, all the way, all the way, all the way till it hits the surface of the Earth, and then the long comes out. So that's why it's A and not D. Portion of the spectrum is outgoing, so that's terrestrial radiation. It's going to be short wave, infrared. Definitely need to do some memorization there. Most infrared given off by the surface is absorbed in the atmosphere by greenhouse gases, and they like to do this one. They take away the most common, carbon dioxide, the second most common, water vapor. They want you to know those other 2. So you got to know all 4. Methane is another greenhouse gas. It absorbs infrared radiation. And then when you're looking at global warming, kind of didn't mention that in the beginning. Maybe I'll make a quick throwback to some evidence for global warming. Carbon dioxide over time, this is called the hockey stick. Carbon dioxide kind of was level, gone up, and then it's just shot right up in the last 100 years or so. So CO2 concentration, what does that do? What's it caused by? Well, it absorbs more heat. It's like adding an extra blanket to the earth, and it's caused by burning fossil fuels. So fossil fuels are made out of carbon-based life. That's where oil and natural gases come from. And when we burn it, we release that carbon back into the atmosphere as carbon dioxide. One more question here. I think this is the last one. You've got the greenhouse. You've got insulation coming in. You've got clear gas. I don't like how they did this here, but I don't like every diagram that the exam does. What's the function of the glass? The glass allows radiation to enter. Well, it does allow radiation to enter. It allows short radiation in, and it reduces the long radiation that can escape. So, not crazy about this question in general because it was tricky. So sometimes you've got to think through it. They put some answers in there that you really could get tricked on. So just make sure you're thinking through short in, long out. That's what it's all about. This is the last question, maybe. Length of time that daylight is received at a location in one day. Duration is length, intensity is strength. So duration, length of time, duration, choice C. All right, this is really the last question. I forgot. It's like you're choosing from the buffet. There's so many good things, you can't not pick them all. Got all these different cities, and they could show a lot of different things with this diagram. Some of them we haven't done the review videos on, but they could talk about where it's going to get more or less rain, warmer or cooler, cooler if you're in the mountains because you're at the altitudes. There's all sorts of different things. But they picked C and D. So here's C, here's D. They picked two that are at the same latitude. So same latitude, one's on the coast, one's in the middle of the country. Annual range and temperatures at D. This is another one compared to C, D. So apparently my son really doesn't like this question. Location D is what we're about. So D will be, the range is going to be less because we're near the water. So A. Hopefully my son likes that answer better than the question. What are the effects of global warming? I don't know if we're going to need these hats anymore. No, that's not true. Just in your hat. But Yuri loves this hat. It's got a little fossil on it. So, effects of global warming. Missed that part. Obviously, sea level going to rise. Okay, as the Earth gets warmer, oceans are getting warmer. So glaciers melt. Disease can spread easier. So there's certain vectors. Vectors are things like bugs that can transmit disease. So as it's warmer in the places that some of those diseases are carried through can expand. Some of those bugs can travel further north and south towards the poles. Disease spread is a concern that people are worried about. And storms. Storms feed off of energy, especially things like hurricane. So if the oceans are warmer, the season for hurricanes can expand a bit. That's one example. And the intensity, how much energy is in that storm system. Hurricanes are predicted to be and have been tracked to be more intense, and the hurricane season is lengthening. So those are the three main things, effects of global warming. Thanks for asking, Yuri. I almost forgot.